Okay, so we have questions 1 and 2. We'll do them in the same video. These are from the exam 2 review for Statistics 250. I'm doing these two questions together because they are similar. They refer to the same topic, the same concept. Okay, so 1. A blank is a distribution of means obtained from samples of a specific size taken from a population. So we're talking about a distribution of means that I get from taking samples of some size from a population. So let's see. Oh, I did that. Let's say, here's my population. Whatever my population is, right? Doesn't matter. And each of these dots, I'm going to make a lot of them. Try to make points. Make my point with points, isn't that? It's wordplay, huh? Alright, so these are all people, things, elements within my population, right? So let's say in my population, I have 1,000 people within that population, right? And I want to take samples of size n equals 150. So each sample I take, I'm going to take 150 people. I can sample the same person or thing twice. Don't have to, but these are all samples that I take from my population, right? Let's say we take 5 samples, and each of those samples has 150 people in it. So red might be my first sample, and the mean of that sample. Let's say we're asking students how many hours per week they're doing coursework during this distance learning that we're working on now, right? So let's say X bar, let's call it X bar 1, right? That mean, the mean of all these people, of all 150 people, the mean amount of hours that they spend per week working on coursework, let's say they spend 40 hours per week. And then the second one, X2 bar, the second sample mean, let's say they spend 52 hours per week on coursework. I don't even know if this is realistic. I don't know if this is how many, I don't know, you tell me. Let's say 40 hours, 8 days. Oh, I guess 5 hours. If there were 8 days, but 7 days per week. What am I saying? 40 divided by 7 days per week. Yeah, 5 and some change. Maybe, who knows? Okay, let's say the third one, it's 31. Fourth one, I don't even know if you can see that color. Let's say their average is 43. And I have one more, right? I have this one, so X bar, the 5th sample mean. Let's say they spend 37 hours, right? So this distribution of these sample means, right? This is the distribution of my sample means. It has a name, right? So I've got all of these sample means from this population, and this is called, oh, let me write in black. Sampling distribution of sample means. It's a sampling distribution because I've got this distribution of means from these different samples that I took. And these samples are all of the same size. It's very important, right? The size of each of these samples has to be exactly the same. So when I take those and I get all the means, that's the sampling distribution of sample means. Now, what can I do with that? Well, I can do exactly what question 2 is asking. So, as the sample size n increases, as this sample size increases, as it gets larger and larger and larger, right? As I get closer and closer to 1,000, the shape of the distribution. So if I was to do some kind of histogram, right, or something with these values, then I would say 40, you know, I'll put 31, I'll put all the values in here on this histogram, taking with replacement from population with mean, et cetera, et cetera. That shape, the shape of that distribution, is going to get closer and closer and closer to a normal distribution. Shape of that distribution will get closer and closer and closer to a normal distribution. So at first, this might be higher, this might, et cetera, but as you take more and more and more, the shape approaches that normal distribution. And that distribution, the mean will be the same as the population mean, whatever the population mean is. And the standard deviation will be this sigma over the square root of n, standard error of the mean. And this entire statement all taken together is called the central limit theorem. It's just a definition, really. But that's how those two questions relate.